This problem is based on the Newton's laws, okay, application of Newton's laws. Here, the traffic light is suspended by 3 cables, and then each is making, these 2 cables are making an angle of, left one is making an angle of 41 degrees, and then right one is making an angle of 63 degrees. And then the third cable is hanging vertically downwards and then holding the traffic light. Now we have to find out the tension in each cable. That is the question. Find the tension in each of the 3 cables supporting the traffic light if it weighs 200 newtons, okay? So what we have to do is we have to resolve the tension is a force, no? And it is, and moreover, it is acting at an angle. So we have to resolve the tension into horizontal component and vertical component, especially for T1 and T2. For T3, not required because it is at an angle 90 degrees with the horizontal. So we need not resolve into components. But T1 and T2, we have to resolve into components because they are at an angle. Now T1 is making an angle 41 with the horizontal beam, and then T2 is making an angle of 63 degrees with the beam. Now resolve them into components. This is T2x and this is T2y. This one T1x is acting left side and then T2y is acting upwards. Now write down the condition because the traffic light is in static equilibrium. The sum of the forces must be equal to 0. So first we will write the horizontal component of the forces or x direction forces. Sigma fx is equal to 0. Now what are the x component forces? T1x is acting left side and T2x is acting right side. So T1x is equal to T2x. Now from the geometry of the figure, this angle is 41 degrees. That is why this angle is also 41 degrees. Okay. So this is the adjacent side. Therefore, T1x is T1 cos 41. And then when it comes to T2x, this is also, this angle is 63. That is why this angle is also 63 degrees. And then T2x is equal to T2 cos 63. Therefore, T1 is equal to T2 cos 63 divided by cos 41. Let us calculate this one. Cos 63 divided by cos 41 is equal to 0.6. Therefore, this is equal to 0.6 times T2. T1 is equal to 0.6 times T2. Now we will write the y component forces. Sigma Fy is equal to 0. What are the y component forces? T1y and T2y are acting vertically upwards. And then T3 is nothing but the weight of the traffic light. Therefore, I will write here T3 is equal to W is equal to 200 newtons. Okay, and then T1 and T1y and T2y are acting upwards. T3 is acting vertically downwards. T1y plus T2y is equal to T3. Now from the geometry of the figure, T1y is equal to T1 sine 41 and then T2y is equal to T2 sine 63 because opposite side these two are. This is the angle, this is the opposite side, and this is the angle, this is the opposite side. Therefore, T1y is equal to T1 sine 41 plus T2 sine 63 is equal to T3. T3 is nothing but T200. Now T1 is equal to 0.6 times T2. I will write that also here. So from this T2, I will take out the T2. This becomes 0.6 sine 41 plus sine 63 is equal to 200. Therefore, T2 is equal to 200 divided by 0.6 sine 41 plus 963. Therefore, T2 is equal to, on simplification, what is the value we are going to get? 155.53. That is equal to 156. T2 is equal to 156 newtons. And T1 is equal to 0.6 T2. Therefore, T1 is equal to 0.6 times 156. Therefore, T1 is equal to 93.6 newtons. Or T1 is equal to 94 newtons. These are the values. He asked us to find out T1, T2, T3. Therefore, T1 is equal to 94, T2 is equal to 56, and T3 is equal to 200. Here is the answer, T2. Okay. I hope this helps. Thank you. Bye-bye.